So section 2 of the lecture, week 6, is going to be about the section of the product development and design for the excellence. We are going to talk about the product development and design, or the PDD, and design for the excellence, DFX. So we start with the product development and design for the excellence. We start with the generic product development of the PDD process. Is going to be start first with the planning. Well, after we're getting the mission approval, we're going to go to the concept development. After we're doing the concept review, the concept review, we're going to go for the system level design. We're going to have the system specific review done, and then we're going to go for the detail design. We're going to check the critical design steps or the parameters. Then we go for the testing and refinements, production approval to be done before we start to do the production ramp up. Now, what's happened in the rapid iteration PDD process? So what's happened is that the two steps of the detailed design and the testing and the refinement is going to be cut to another three steps: design, build, and test. And we get to have many iteration cycles to be done for design to be upgraded, or simply it's going to be refined, and then we're going to build and test. So instead of having just one design, do the testing and ramp up the production, we're going to check it multiple times, do refining until we're going to have the final product to be starting the production process. Now we have the complex system BDD process. So the same steps in the middle of the design and the test is going to be for multiple products in parallel. Okay, multiple products in parallel. So this will save the time, so that some time is going to cause a cost to be increasing. But now with the digital format, you can simply make a simulation for multiple different designs, and you're going to have the output. You can do a simulation for the part, different designs, different teams working on different designs, and at the end, you can have the evaluation to get the best design among all. Then we're going to do the integrated and test for the final successful design before we're going to start the production approval to validation and the ramp up of the production. Now, the characteristics of the successful product development are going to be: first, the good product quality, the product cost, the development time, and the development cost. But we still have challenges for the product development, which are going to be the trade-offs, the dynamics, the details, time pressure, and the economics. Usually, we are going to link that to the creation, the satisfaction of the social and the individual needs, the team diversity, and the team spirit. So usually the design and research team will consist of multiple sections. So the inner circle is going to be about the people who actually working on the design. The team leader will be connected to the manufacturing engineer, the purchasing specialist, the electronic designer, the mechanical designer, the industrial designer, and the marketing professional. So that's what we call the core team. We still have another circle outside, which is going to be the extended team. That's including, for example, the finance, the sales, and the legal, which is going to do the process like the patterning, the providing the research funds, and also to provide the future buyers. So the main process is going to be the marketing, design, and the manufacturing. The product development organization can be run in different ways, as we mentioned earlier. You can have the functional organization, which considered to be the oldest and the worst among the others. So you can see here that we're going to have one general manager who is going to work with sub-functional managers in different teams. So you can see that every one of the teams is going to be specialized in something. Like, for example, the triangle is going to be for the mechanical engineers. The circle is going to be for the electrical engineers. And the last one, let's say, is going to be for the electronic engineers. So just imagine that you try to work in a functional organization to design new products. You don't have actually a link between the different groups, and thus you are going to work in parallel lines, and at the end you have to match the ends, and this will be a very hard task. So what we can do instead, we can use the project organization, which is going to be a little bit more effective. So we're going to have different teams, and from these teams, we're going to have different people from different um, backgrounds. So the general manager is going to talk to a project managers instead of the functional managers. So every one of the team can actually have a discussion between them and have a review of their works to see, for example, if the material has been selected, is going to be easy to manufacture. And if the property of this material is going to be good in terms of the electrical conductivity. Okay, so you need to have manufacturing engineer, you're going to have a metrology engineer, again to have an electrical engineer in one team, so they can simply finishing the product in general as a one project, and then reporting the general manager. This can be done for different assemblies of the part, sub-assemblies, and they're going to have the final assembly for the project. Now, the other way we can do it is by working as a lightweight project matters organization. So you can see that we can do, instead of having the teams to be divided into multiple sections, they can still work in as a functional organization, but they're going to have the close links between the different types. And that's what we call the lightweight project matrix organization. So again, to have a multiple officers from multiple backgrounds and to link between the work in different the functional organization sections. The heavy one, in that case, is going to be the same one we had there, but now the link is going to be between the similar specialty in every team. So in general, what we need to do is a project team, which is going to be the best way to run the projects. So we're going to talk now about design for the excellence. Design for the excellence is a series of development and practices in which the X corresponding to one of the dozen of the quality criteria, such as reliability, the robustness, the serviceability, the environmental impact, or the manufacturability, and extra. So, for example, we can see that the different types has been listed here, and that's actually can be extended even further. Design for the manufacturability or manufacturing, or we know it as a DFM. So when you design a product, you will need to know actually how I'm going to manufacture this product using an easiest way, less energy, and for example, the best material for manufacturing to be used. Design for the assembly is about the making the assembly time to be shorter because the assembly time mean money. Design for the environment, we check in the impact of manufacturing every single part on the environment. Design for safety is understandable. Design for the inspection is understandable, variability, and the cost. So everything is about optimizing the design process to the optimum outcome and the different X. So the implementation of the DFX in the PDD, you remember that we said planning, concept development, system level design, detail design, testing and refinement, and the production ramp-up. So we're going to have the DFX to be implemented on. Now, we said that we have concept development. This will be part of the design. The system level design is design. The detail design is a design. So this is going to be within these design steps. And you can see that the star are going to tell you how much involvement we're going to have in each. So most of the involvement is going to be in the detailed design. We're going to have the DFX to be involved in every different section. Okay, now this is the end of the section 2, and we're going to move to the section 3, which is going to be about the design for manufacturing and assembly.